In question 5, we start off with trigonometry, and they told us with the aid of a diagram, so that means we're going to have to do a sketch. And if we're going to do a sketch, we need to decide what quadrant we're going to be working in. So first things first, we need to grab this 3 sine beta equals 2 and get sine on its own so that I can assess whether sine is positive or negative. In this case, we can clearly see that sine is positive based upon looking at this fraction here. And then we're going to draw a little cast diagram, and sine is positive in the first and second quadrant according to your cast diagram. Then we come and have a look over here. Now this is very sneakily telling you that cos is negative, and cos is negative in quadrant 2 and quadrant 3 because it's positive here, so it has to be negative in those two. Now we set up a sketch in the second quadrant where this obtuse angle over here is our angle beta, and then this will adopt the place of our reference angle. And we come have a look over here, and according to Sokotoa, this must be the opposite and this must be the hypotenuse. So we're going to fill it in on the sketch accordingly. The hypotenuse is opposite this 90-degree angle. It points at the hypotenuse. So we'll fill a 3 in there and 2 opposite the reference angle. Now we're going to make use of Pythagoras to work out the missing side. And we start off that process by just calling this side x because it goes left and right. And then I'll say the hypotenuse squared, 3 squared equals this squared plus this squared. Okay, once that's out the way, 3 squared is 9, 2 squared is 4. And if I take that 4 over, it becomes minus 4. So 9 minus 4 will give me 5. And then to get rid of the square on x, we need to square root both sides. And then just don't forget the plus minus in front of the root when you do that step. Now we've got to choose the right one according to where it is on the Cartesian plane. This is the positive x-axis, this is the negative x-axis. So we're definitely going to have a negative x value. So we're going to choose negative root 5. And after all that set up, we're finally ready to answer this question. So the best place to start is you keep the structure of the question the same and you change cos to an empty bracket like so. And then we're going to go get cos beta using ka from the sketch and put it inside this empty bracket. So let's go ahead and do that. Cos is adjacent over hypotenuse. So adjacent to my reference angle is minus root 5 and the hypotenuse is 3. So we go ahead and slot that in here. Once that's out the way, I square the top and I square the bottom and I do not touch anything else. If I square root 5, it's just 5, and if I square 3, I get 9. And bear in mind, a negative times a negative is a positive, so this negative essentially disappears. Now we need to simplify. So we start that process off by putting this 3 over 1. We find the biggest number that can go into the top and the bottom. I can divide the top and the bottom by 3. So 9 divided by 3 will give me 3. And 3 divided by 3 will give me 1. And now I just do top times top and bottom times bottom to get my new fraction over here to be 5 over 3. And this whole time the minus 1 just chills on the outside. And now 5 over 3 minus 1. Convert that 1 into a fraction quickly, 3 over 3. 5 minus 3 will give me 2. So the final answer will be 2 over 3. And we have officially wrapped up this question. Quickly having a look at your 4 marks. Quadrant 2, the value from Pythag, substitution of cos beta, as well as your answer. In question 5.1.2, I so desperately want to reduce this guy, but I can't. I can only reduce it if I see these 3 things, 180 minus, 180 plus, 360 minus. So there's a simple solution to that problem. We just need to add 360, and then we're going to get back to a familiar territory. So minus 180 plus 360 gives me positive 180. And then I put the positive 180 first, and I put the minus beta second. And now we set up for that reduction. You see we have 180 minus. So in that quadrant, tan is negative because only sine is positive there. So we reduce this to negative tan beta. And now I'm going to replace tan beta with an empty bracket, keeping everything else about the structure the same. You see how the minus stays behind? Now tan beta, I'm going to use TOA and my sketch to fill it in. So tan is opposite over adjacent. It's all relative to the reference angle. So the opposite is 2 and the adjacent is minus root 5. So inside of this bracket, I put 2 over minus root 5. Negative and a negative cancel out to give me a positive, and I'm just left with 2 over root 5. And your 3 marks will be awarded for your reduction, substitution, and answer. In question 5.2, we've been given that t cos 15 equals 4, and we need to determine the following in terms of t without the use of a calculator, sine 15 and sine 75. So without the use of a calculator is a serious clue that you actually need to do a sketch. And if we fall back into our procedure with sketches, I want cos of 15 on its own. So I want to get rid of this t. And we're going to accomplish that by dividing both sides of the equation by t. And then they cancel on the left-hand side over here. And I'm left with cos of 15 degrees equals 4 over t. And then we analyze this line like so. Because we're working with cos, that is the adjacent over the hypotenuse, so this top number is representative of the adjacent, bottom number represents hypotenuse. Now 15 degrees is in the first quadrant, so we're going to set up a sketch that is in the first quadrant. So just think of your bow tie when you go ahead and sketch this triangle, and then this 15 degrees is always the angle that is closest to the origin, so we just fill it in over there. Then I always like to work this angle out using interior angles of triangle. 180 minus 90 minus 15 will give me this angle to be 75, and hey, would you look at that, they're going to test it. That's why I always get it. And then we fill in our adjacent and hypotenuse. So adjacent to the 15 will go the 4, and our hypotenuse gets filled in as t because that's at the bottom over here. Now to get this missing side, we're going to use Pythagoras. And we'll start off by naming it y, because it goes up and down. So to start off with Pythagoras, it's my hypotenuse squared equals. So my hypotenuse goes first, that's the t because it's across from the 90-degree angle. And then it equals to this side squared plus the side squared. Now that 4 squared, we are going to yoink it over to the other side. The whole goal is to get y on its own. So if I yoink it to the other side, it becomes minus 4 squared. 4 squared is 16. So I just square root both sides to get rid of this square on y. And we get y to be t squared minus 16 underneath a square root. And we just replace that y with the t squared minus 16 under the root. And now we're finally ready to answer the questions. So sine of 15, I'm going to use saw with the 15. So sine is opposite over hypotenuse. So if I go to the 15, opposite over hypotenuse, so it's the root over t, just like this. Okay, we're going to do the same thing for sine of 75. So if we have a look at sine of 75, this is now our reference angle. So opposite over hypotenuse, opposite the 75 is 4, and the hypotenuse is t. So this will just evaluate to 4 over t. And then we've officially wrapped up this question. Quickly having a look at your marks. 1 mark for isolating cos of 15. 2 marks, 1 for that square root and 1 for t. And then 2 marks for the answer only in this question. And rounding out question 5, we need 1 minus tan squared 15. And we need to give the answer as a single fraction. So how we cope with squares is we kind of like put them on the outside and we replace tan of 15 using TOA and our sketch. So let's go ahead and get tan of 15. Opposite over adjacent, I'm using 15. So opposite over adjacent, the root over 4. Now I give priority to the square. So how I get rid of it is I square the top and I square the bottom. If I square the top, it's going to cancel out with this square root over here. And if I square 4, that will give me 16. Now we need to focus on turning this into a single fraction as they instructed. We're going to do that by getting the LCD. So the LCD will be 16. So I need to change this 1 to 16 over 16. Now we're going to morph these guys into one big fraction. So I'm going to draw a big divide line with 16 at the bottom. And then I'm going to say 16 minus this guy in a bracket. Don't forget a bracket. You're subtracting the whole thing. So it's 16 minus t squared minus 16 in a bracket. Okay, we're going to distribute that negative into the bracket. So we're going to get a sign change happening over here. And then we just do our like terms. 16 plus 16 will give me 32. So I can change that at the top. And we'll just be left with 32 minus t squared over 16. And now we've adhered to the instructions. Our answer is a single fraction. So let's have a look where our 3 marks will come from. Substitution of tan 15 gets you the first mark. Squaring that bracket correctly gets you the second mark. And the correct multiplication for your LCD earns you the third mark.